All right, so we are on 3.68 roots and radicals. This is our last section of unit 3. Oh, and then we have unit 4 left, and there's 2 sections in there. But 3.6a roots and radicals. We're going to start off with defining some stuff. So first up, we are going to talk about what are real number roots of each radical expression is what we're trying to find. The key word here is real numbers, okay? We've talked about complex, right? Those are our imaginary friends, but we're back to not focusing on those, right? Only focusing on the real. Got it? All right, so for any real number, A and B, any positive integer n, if it's A is raised to the nth power, then B is the output. It equals B, right? Now, its inverse is a radical, okay? The inverse of raising something to the power is to find the radical of it, all right? Your n is now your index. Your B is now what we call your radicand. And your A is now your output, okay? They're inverses of each other, all right? So with that being said, we're then going to define there's a difference between an odd index and an even index. When you have an odd index, your radicand can be positive or negative. So your radicand can be positive or negative. Your radicand can be positive or negative. And you're only going to have one real solution. Okay? Now, if it's an even index, so if it's an even index, your radicand can only be positive. Can only be positive. Okay, so if it's an even index, meaning 2, 4, 6, 8, who do we appreciate, right? It can only be positive, and it's going to result in 2 real solutions. And the reason why it results in 2 real solutions is because a negative times a negative is going to always produce a what? A positive, okay? So you can have, you're going to have your positive solution and your negative solution. One real, okay? So if it's an odd index, meaning 3, 5, 7, etc., your radicand can be negative and or positive, and you're only going to have one real solution. If it's an even index, 2, 4, 6, etc., it can only be a positive underneath the square root, the root, the radical sign. Okay? So the plus or minus are my 2 real solutions. I'm going to have a positive solution and a negative solution. Okay? All right. Questions about vocabulary and what things are allowed to be so far? Good? Okay.
What is that? Is that E/Z?
Etc. etc.
Oh, it looks like E-Z. And that looks like ELC.
I see it. That's like ... until you continue. All right. So now we're going to move into some examples of how what's being applied, okay? So at the top, it says the blank. This is your index. The index tells you how many in a group you want to have, okay? Now, how many of you remember this? Prime factor trees. Mm-hmm. Yes. Prime factor trees ring a little bit of a bell. Okay. A prime factor tree is when you're breaking a number down to its factors, right? It's prime factors. Our prime factors being 1s, 2s, 3s, 5s, 7, 11, 13, blah, 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 right? Breaking that down. Okay. You do this because it says that your index, the number outside, is telling you how many like factors you want in a group. Okay. So right now our index is what? 3. So I want to know how many groups of 3s can I make from the number 343. Okay. In order to do that, I need to break down the number 343. So I go through a series of like number sense skills. So I'm looking at 343 and I'm like, it's not even. So is it divisible by 2?
No.
No, it's not. All right, 3. Ooh, it may be divisible by 3. A number sense skill for 3 is if I add up the digits and it doesn't equal a multiple of 3, it is not divisible by 3. So I have 3 plus 4 is 7. 7 plus 3 is 10. Does that equal a multiple of 3? No. So is it divisible by 3? No, it is not.
Wait, did you talk about that when you did?
It doesn't matter what order you add in. Yeah, addition is commutative. All right. So it's not 2 or 3. It's clearly not 5 because it doesn't end in a 0 or 5. If it's not 2 and 3, then it also can't be 6 or 2 or 6 or 4, right? All right. Next guess, 7, right? We want to start small with our primes. Will 7 work?
Yeah.
Yes. Okay. In 4th grade, my teacher taught us what's called shorthand division. 4th grade is when I decided I love math and I want to be a math teacher. I know that sounds crazy, but that's when that realization happened. Okay. So 7. Shorthand math is saying you're starting off asking yourself in your head, what can it divide into? So can 7 divide into 3? No. Can 7 divide into 34? Yes. How many times? 4. It divides in there 4 times, which is 28, with a remainder of what? 6. So that 6 is going to be a little number here. 7 goes into 63 how many times?
9.
9. So 7 times 49 is 343.
I didn't know.
Well, we can find all the clues for the other one, but 7, you just had to test it out.
Oh, okay.
Yeah. But a good sign is that if a number ends in 3s, you want to check 11, 7, 13. Think of the numbers that on your multiplication chart that have a 3 in the ones place.
It's only because 7 can go into 34 4 times. You got the 7 in 4th place. And then 7 can go into 6 because you put the invisible 6.
Mm-hmm. And then 49 breaks down to what? 7 and 7. My index is 3. I want to know how many groups of 3s can I make? I only can make how many?
3.
1. I can make 1 group of 7.
Wow. Wait.
Yeah.
Okay.
So this means that 7 times 7 times 7 equals 343. So therefore, the cube root of 343 is 7.
Well, how did you get that from that? Hold on.
Okay.
You circled it and it was like 7 with the 1, and it was like, how did you get the 7 with the 1? Like, how did your brain say that 7 with the 1?
So we said that this number, this 3, that's our index, and it's telling us how many in a group we want. And we want how many in a group? 3. I can only make 1 group of 3 7s.
They have to be the same number?
They have to be the same number. Yeah. You only can make 1 group of 7.
And I got one.
Huh? Exactly, because I only have 1 group of 7. How did I get 7? Yeah. Because the factors 343, its prime factors are 7, 7, and 7. 49 isn't prime. 49 is a composite. Okay.
But when you were thinking it, you were thinking 3 doesn't go, 4 doesn't go, 5 doesn't go, 6 doesn't go. How did you pick 7? I
tried 7 because I know that I can multiply 7 times 9 to get a 3 in my ones place. Because 7 times 9 is 63. Like you're looking. You asked me, how did I know?
Yeah, how did you start? Like, okay,
you remember when
you're like 3 plus 4 plus 3, that's 10. So like,
3 doesn't work. So remember, I said we're going to start with number sense. So looking at the number and kind of going through what we should know how numbers work. So we said we know 2 doesn't work because it does not end in an even number. So it can't be 2, right?
4 or 6. It's going to be 1 to 9. Every single time it's going to be 1 to 9.
No, your numbers could be bigger. But I'm just saying you start with the basis of it. Yeah, you just start with your base and then go from there. That's why you learn your 12 by 12 multiplication chart in middle school, right? That's your foundation. It doesn't have to be the biggest because you're breaking it down. Like you're factoring it down. No, there will not be more than one number that will multiply 3 times to give you 343. When you're taking the square root, a cube root or something, you're saying what number times itself, this number of times will equal this product.
So that was 2 and it was a number, if it was just 34 and 3 was 2, we can only find 2 groups.
If your index was a 2,
yeah,
yes, then you would be grouping 2 7s together.
Yeah. Okay.
Yes.
I'm getting it. So like, yes, basically. Like,
yeah, so you're using number like common sense, math sense to figure out what I can divide into this. So like whatever number skills you have, huh?
So just keep on going until we find out.
Yes. Okay. I don't know what I said wrong or why people are lost or confused.
So when you got 7, or what percent how you got 7?
I just started from 1.
Well, when you started doing 34, 7, 6, 3,
I divided.
yeah, that's
I just didn't want to do long division on the side, and I didn't have a calculator. So I divided mentally. That's all I did. Mental division. That was it. Nothing else, nothing more. Just mental division. That was it, mental division. 7 goes into 34, 4 times. Remainder of 6. 7 goes into 63, 9 times. That was it.
okay. Next question.
Okay. That went a little longer than I thought. Here we go. On B. B is a fraction. When you have a fraction in a radical, you're finding the root of the numerator and of the denominator. It's not just of one. Okay. If the whole fraction is underneath the radical, you're doing the top and the bottom. Okay. So notice here we have the 4th root. So our index is 4. So that means I want to make groups with how many in them? 4. Okay. Now, any root of 1 is going to be what? 1. So I know that it has to be a 1. Does that make sense? Because my index is even, I know that it's going to be a plus and a minus. I'm going to have a positive solution and a negative solution. Okay. For 625. Say that again. Yes. So we're going to break down 625, right? Okay. And the reason why I know I can start with 5 is because what? It ends in a 5, right? Using that number sense. That's all we're doing. So 5 goes into 6 1 time. Agree? 5 does not go into 2. So that's 0. And 5 goes into 25. It's not.
No.
Oh, wait, 12. What did I do? 125. I didn't mean to do that. I meant 12. So 5 goes into 6 1 time with the remainder of 1. 5 goes into 12 with the remainder of 2. 5 goes into 25 5 times. My bad. I don't know what I did in that moment. And then 125 is what?
Why is there a 1 but 2?
Because I had a remainder of 1.
But let me put 1 next to 2 and not down there.
Guys, I'm just going to show y'all really quick. This is called shorthand division. All I'm doing is preventing myself from writing all of this out. This is it, guys. That's all I'm doing. That's all that this is. Shorthand division. Nothing different. You have the foundation of division. You know how to divide. I'm not taking anything away. It's just that this is how you learn in 3rd grade. And again, my 4th grade teacher, super awesome. And he taught us shorthand so that if you're comfortable with this, you can do that without all the work. That's all I did. I repeat.
So do I, on 125, do we flip out?
Yes.
And then you go to 12, 2 times.
And 3? I don't know that. Well, 3, right? Why is it then 25, right? Oh, it could be 25. No.
Okay. So y'all, that's all I did, right? Are we okay? Okay.
Yeah.
All right. So then the next thing you're saying, I want how many prime numbers in a group? 4, because my index is 4. Well, my prime numbers in a group, I only can make one group of 5, right? So the number is 5, and I only have one group.
Okay, I'm getting it. Which is
So this is plus or minus 1/5. Yes? Okay. Here, my index is 3, but this time I have a decimal and a negative. Because I have a negative, I know that my answer has to be negative. And because I have decimals, I know that my answer is going to have to be a decimal. Does that make sense? I know it's a negative and I know it's a decimal. Good? All right, now we're going to start with, you can't do anything with the 0, so you're only looking at 64. In your brain, you're like, how does 64 break down? You're like, oh, 8 and 8. All right, that is not a group of 3. That's only a group of 2. So I got to break it down a little bit more. 4 and 2. 4 and 2. Still, only pairs, not groups of 3. 2 and 2. 2 and 2. Do we see that? Okay. Yes? So now I need to make groups with how many in them? 3, because my index is 3. So there's a group and there's a group. So my groups are made of 2, and how many groups do I have? So this equals 4. So the cube root of negative 0.064, you square it out. So 2 squared. So this would be my answer. If you don't believe yourself, then you're asking yourself, remember, this is saying what is negative 0.4 times negative 0.4 times negative 0.4. Well, we know that it's going to be negative because I have an odd set of negative. And if I have 40 cents and I keep breaking down 40 cents, it's going to become worth less. Does that make sense? And that's what's happening here. And that's why you end up with negative 64 thousandths. Okay? All right. D. When there is not an index on the outside, that index is automatically a 2. When there is not an index, it is automatically 2. Make sense? Haven't we already seen square roots before? Yeah, so it's automatically a 2. All right, so when I look at this, I have an even index. And if I have an even index, what is not allowed? A negative. This is a problem for an even index. Because I have an even index with a negative. That means I have no real solutions. And there's nothing more that I have to do. So the difference between C and D is that C had a odd index. And so good to go. However, D had an even index and I can't go any further. Exactly. And the reason is? Exactly. It's an even index. Okay. Looks like on my board.
No, you have a
Warning. All right.
right here.
All right, here we go. So I would like for you to try. Okay. We're only going to do 1 through 6 in class, and then the rest are for you to practice independently. Okay. If you're wondering why there are baby calcs on your desk, it's because that's what you're allowed to use. On your quiz on Friday, that's also all you'll be able to use. So they were only 60 cents, so that's possible.
But I set it down, I can see it. If I pick it up, I can see it. And like I push the button, nothing happens.
Good thing there's 4 other on your desk.
No.
Really, because of the color. Oh my They're fragile. Don't drop them.
Wait, when I get the number on top, is it the groups? Or
Your index is your group. The number outside of the radical,
yeah.
that's how many are in a group.
Okay. So on number C, when we put 2, 2, the big 2 is from the 2 groups, or was it the numbers in the group?
The big number is what's in the group.
Okay, so it will be.
Bro, how do you find what the
Can I just multiply these two numbers together and get that number?
Because you need a group of 3, right? Doesn't matter how you get that group of 3, but
So on 3, is it 0.21?
on 3, how did you get that?
Because we don't do decimal, so it'll be 4, 4, and it would be 2, 2, 2, 2.
So just 0.2. Where are you getting the 1 from? 2 to the 1, like a power, a little one? Oh yeah, which is just 0.2.
It's better when I put 1.
Okay.
So 3 is 0.2.
Yes. Remember though, for even index, they have to be what? Good one. There you go. What's wrong?
I still get hard to find what the I think it is.
It's just kind of more of like a essentially a guess and a check situation.
But I'm guessing, like, it's not any, you know. So it could be that.
Yeah.
Is that a group?
Yeah.
So it's okay.
You really made it come over here with my onion breath. I bet they didn't eat. I ate my salad that had onions in it. I threw them up half of the way for everything to eat it in. Okay, what's up?
1, 3. 1, 1, 1.
So you have start and not even what? There you go. There's no plus or minus because it's only have plus or minus if it's only the first
If it's odd, it's only 1.
yes, odd only has 1 solution. See. Okay, so this remember even. All right, so on this one, I do the 8. 9 times 8 is not 7. I just put it in the 9 times 8.
Oh, 89.
Oh, I was like, girl, we're missing some stuff. That's what's wrong.
I put 9.
Anyway, that's this part's wrong then, because 2004 does not make 81.
But this was on and I saw it 9. I do not care.
Yeah, it's supposed to be quick. So 9 has the same trick as 3. You add the digits and they equal a multiple 9 and you know it's equal 9. So this equals 18. Like 7 equals 9, that equals 18, right? And 18 is a multiple of 9. And you know that it's equal by 9.
How about I gonna do this 17?
And 9. No plus or minus, only one. This is odd. Everything plus or minus.
Hey, pardon this interruption. Did it? We're about to sit down for 5 minutes. Go back in the building. Don't get into that. You guys don't know how to do it. Please make sure all of you grab their stuff. Once they make the building, they will talk it out. Thank you.
All right, guys. I will not. Well, I may see y'all tomorrow, but in case I don't, I will make the video, and you will have access to that. Okay. Okay. So let's check and see how you did. So if you have the square root of 169, well, this one is kind of like remembering a little bit of our multiplication chart, but remember, there's that invisible 2. So 169. Hopefully by now we all know that it's 13. And that's just a pair of 13s. So it's going to be plus or minus 13. Okay. Here we have the cube root of 729. So 729, looking at it, I can divide by 9. That's going to give me 81. 81 becomes 9 and 9. Now notice here that I already have a group of 3s. My index is 3. So I just need to be able to make a group of 3. Since I can already make a group of 3 here, then I know the cube root of 729 equals 9. Okay, 4, with 3, our index is 4. And again, it's a decimal, so I know that my answer is going to have to be a decimal. It's a even, so it's going to be plus or minus. So I'm going to focus on 16. 16 becomes 4 and 4. That's only a pair. I need a group of 2. And so here's my group of 2. I have 2s, and it makes one group. So therefore, this is plus or minus 2/10. Okay. I have the cube root of negative 1/8. The cube root is going to be negative because it's already negative. Any root of 1 is going to be 1. So I know that my numerator is still going to be 1. 8. Well, 8 is going to break down to 4 and 2. So the cube root of 8 is 2. So my answer would be negative 1/2. I have a square root. Again, nothing there means it's a square root. I know it's going to be plus or minus. And this is just asking, what's the square root of 4? 2. What's the square root of 121? 11. So therefore, it is plus or minus 2 over 11. Okay. Cube root. So cube root of 125 over cube root of 216. What is that going to give me? So 125, in my mind, I'm like, okay, it's 5 and 25, 5 and 5. Here's my group of 3 based on my index. So in my numerator, I know it is 5. 216, so I'm going to break down 216. 216, I'm going to use 3. That's going to give me 72. I'm going to break down 72. That's going to give me, I can do 8 and 9. Break down 8. That gives me 4 and 2. 2 and 2. Break down 9 gives me 3 and 3. I have one group. I'm going to finish it out over here. One group of 3. And I have one group of 2s. Notice that I have 2 separate groups, so therefore they're being multiplied. So the cube root of 125 over 216 is 5 over 6. Okay, so as you continue going through this, there are more practice for you. So practice that skill, and when you are done, check with a peer, come and talk to me if there's one that you get stuck on, but it's the same thing that you're doing, breaking it down and analyzing, okay? You got this.